During this video, we will look at adding and subtracting fractions. It will be adding and subtracting like fractions, mixed numbers, unlike fractions. We will also include our integer rules of adding negatives and subtracting negatives, etc. We need to remember all of those, and we'll get going on it here. Alright, so we're going to look at a simple addition problem with fractions here. Start off at 8/10 plus 8/10. Okay, so addition and subtraction, both, your denominator stays the same. Once you get it to like terms, it stays the same. So we want to make sure it's there. 8 and 8 is 16. You now have 16 pieces out of 10 that make one whole, so we're going to pull one whole out. It's going to leave us with 6 over 10. We can reduce that by pulling the greatest common factor of 2. So we can go with 1. 6 divided by 2 is 3. 10 divided by 2 is 5. So 1 3/5. So there you go. That's that one. Let's go ahead and do a different one. So let's do with 3/7 plus, let's go with 2/7. Okay, so again, denominator stays the same. We add those across. We have 5 over 7, just like that. Okay. Alright, so let's go with another addition. We'll do 5 and 6. Let's go with 12 plus 6 and 6. And let's go with the 8. Let's make that an 8 12ths. Okay. So first thing, let's pull out our wholes. So we have 11. And again, we still keep our denominator the same and just add straight across. So that's 14. Now we have a improper fraction. We have 14 pieces out of 12. That makes one whole. Let's pull out a whole and add it to the 11. So we're adding one whole out of there. That's going to leave us with 2 pieces out of the 12 needed for a whole. We can also reduce this. That's 12 and 1/6. Okay, so the process is the same here. We have 5 wholes plus 6 wholes equals 11. 6 12ths plus 8 12ths equals 14 over 12. And then we want to pull one whole out of there and add it to our 11 here. That gives us our 12 and our 2 pieces left over. And we can reduce that down to our final answer. Alright, for this problem we're going to add unlike fractions. We have 1/6 plus 2/3. Okay, so we have to get a common denominator here. This one's fairly simple because our denominator can easily be a 6. We'll just convert this into 2 times 2 into 6 is here. 1/6 plus 4/6 is 5/6. Okay, so say we have something different. That's a little simple because it's a common factor, common multiple. You should know these math facts, basic here. So let's go with 7 and say 15. Okay, give us a 2 and a 3. So sometimes with some of these, the easiest way to do it is just to multiply each by the number that is seen. It doesn't necessarily have to be done that way, but you can. And then you have to reduce it afterwards. So let's just go with, I'm going to stick with 15. And then 7 on this side. Because we want them to be the same. So whatever you do, you have to do to the other side. Top and bottom. And then make them equal. So we have 30 over 7 times 15, 35, 7 is what, 105? Yep, okay, so then we have 105 as our bottom, and then 21 equals 51 over 105. Well, I don't think anything goes into 51, so we're going to be set there with 51 over 105. All right. Okay, so let's move on to subtraction. We have negative 8/10 minus 9/10. Okay, remembering our negative integers and the rules for that, we're adding a negative or we're taking away from negative. So we're going to go farther left. All right, so it'll remain negative. First thing. Next thing we need to do is take and remember our denominator stays the same. So we will end up with a negative 17. Now, reducing is still the same. It's 17/10. We have 17 pieces out of 10, so we're going to pull one whole out. Sign stays the same. Okay, so that leaves us with 7/10. That cannot be reduced, so that's our answer for that. We also have, let's reverse this. We'll do 9/10 minus 8/10, just to have the basic. Okay, so this is going to be 1/10. Subtract across, this moves over. Same deal. Okay, same as addition, same denominator stays the same. Alright, we have 5 3/8 minus 2 2/8 here. I'm going to subtract out the whole numbers. It's 3, comes straight across. 3 minus 2 is 1. Our denominator stays the same. Okay, so let's go with a 2 3/8 here. Minus 5 2/8. Okay, so we'll do the whole numbers again. That's going to be a negative 3. Come straight across the same. Be 1/8. So we just need to remember our integer rules and stuff when we see these, because we may see this as a negative 5 3/8 plus a 2 2/8 or minus a 2 2/8. All sorts of different variations on this. Just remember your basic rules, put them together. That's all we have to do for them. There you go. For this set, we will do a mixed fraction that is unalike and a regular fraction that is unalike for subtraction. Let's go with we'll use the same bottoms. So we have 4/5 minus 2/9. We need to make those equivalent on the bottom. Simplest way is just to give it our multiplication is 9 5. So we will have 9 times 4, and then we have 9 times 5. And then subtracting a 10 45ths. So then just subtract right across. That's 26 over 45. Now, can we pull anything out of that? Can we divide out? Let's see. I don't think we can, because we have 45. Not much goes into that between 9. 9 doesn't go into 26. Does 3 go into it? Sure, 3 go into 45 and 26. I don't think we have anything that 3 goes into 26, because we hit 21, 24, and 27. So nope, we don't have anything there. So that's your basic one. Just multiply, get a common denominator, and go with that. And then we have a same deal, but with mixed numbers. So this one's going to be a negative, obviously, because our second fraction is bigger. So let's go ahead and do our whole numbers. It's going to be a negative 3. 7 minus 10, negative 3. And then we have the same. We'll have 36 45ths minus 10 45ths. Okay, so it'll be negative 3 and 26 45ths. And so again, all I did was take this up top, apply it to here. We got a common denominator of 45. Then subtract it straight across. Kept our denominator the same. That's it.